So hello, I'm Dongbai MAT2409008. This is my video presentation project for MAT201 Mathematical Analysis 1. My topic is about L'Hopital's rule. Introduction. Limits. We know that limits are important in both calculus and mathematical analysis. But when we need to calculate the indeterminate forms such as 0 over 0 or infinity over infinity, so the common direct substitution doesn't work. But L'Hopital's rule provides a good method to solve the limits like this 0 over 0 or infinity over infinity. Okay, let's look at the statement. What is L'Hopital's rule? Let f and g be differentiable functions near point A. It's open interval except for suppose that both fx and gx approach 0 as x approaches 0. So x approaches to 8. So when x approaches to 8 is 0, the limit is 0. So if the limit of the ratio of their derivatives exists, if this one exists, then the limit of their original quotient also exists. So this one also exists, and they have the same value. So this is equal to this. Both they are L. So in the proof, we need three conditions. Both numerator and denominator must equal 0. Functions must be differentiable in A. The derivative of the denominator cannot be 0. So these three conditions ensure that mean value theorem can be applied. We need to use the mean value theorem, use the Cauchy mean theorem to prove the L'Hopital's rule. Okay, so the proof is based on Cauchy mean value theorem. It's really the change of function to their derivatives. The key idea here mentioned the key idea is to replace a difficult limit by a simple one. Okay, this is the Cauchy mean value. Let's remind what is Cauchy mean value theorem. So there exists a point C. C is from A to X, between A and X, such that this equation holds. So this theorem conducts a change of functions of their derivatives. Okay, and there is a proof. Since both functions support 0, we may assume that fa equals ga equals 0. So then the equation simplifies, and we obtain that the ratio of fx and gx equal the ratio of their derivatives evaluated as the same point c. So the derivative of fc over gc, so they are equal. And the next step, we need to take a limit as x approaches a, the point c also approaches to a. So by taking limits on both sides, the limit of the function ratio equals the limit of the derivative ratio. So we finish the proof of L'Hopital's rule. Okay, let's look at this is an easy example. Consider the limit of sine x over x as x approaches to 0. Because we found it is sin 0 over sin 0 is 0 over 0. So this is the indeterminate form. So we need to apply the L'Hopital's rule. Okay, just the sin x, the derivative is cosine x. X become 1. Cosine x, when x approach to 0, cosine 0 is 1. So it's 1 over 1. The final answer is 1. This is easy but a classic example for the use of L'Hopital's rule. Okay, so let's consider a more challenging example. This when x approach to 0, we can e0 is 1 minus 1 minus 0 is 0. X square 0 square also 0 is indeterminate from 0 over 0. By direct substitution, so it cannot be solved. So let's use the L'Hopital's rule. So we first derivative the numerator, e of x become e of x minus 1, so it will is nothing, is 0, yes. And minus x become minus 1. And this x squared become 2x, the derivative is 2 plus x, 2 times x. So the limit is this one, and then we can calculate e0 is equal to 1 minus 1 is also 0, and 2x is also 0, it's also 0 over 0. So when we meet this situation, we need to use the L'Hopital's rule for the second time, so it becomes e of x, so it becomes 2. So the final answer is 1 over 2. So maybe we will use, after use the L'Hopital's rule, we will meet a indeterminate form again. So we need to use the L'Hopital's rule for 1 time, for twice, for 3 times, or many times. It's possible. Okay, the L'Hopital's rule simplifies the limits with determinate forms. Its proof is based on the Cauchy mean value theorem. It's an important bridge between limits and derivatives. The rule is widely used in calculus and analysis. It provides an effective method to evaluate the indeterminate forms. Okay, so that's all. Thank you for listening.